Hey guys, welcome to day 2 of Stats Online, also known as April Fool's Day. Now, unfortunately, it's not April Fool's, but I am going to tell you that today is going to be a really straightforward lesson, because what we're going to do is we're going to do problems very similar to the ones that we just did on Monday. However, we're going to be doing it with non-normalized or standardized data, so we can show you how to standardize your data and then actually find the probability. Okay, all we're going to do is 4 example problems, and it's going to be pretty much exactly like what we did the other day. All right, so first problem. Okay, number 1, it says the average cost of a 20-ounce soda is $1.17. The average cost of a 20-ounce soda is $1.17. If we have an approximately normal distribution with a standard deviation of 11 cents, what is the probability that a randomly selected soda is less than $1? Okay. For these problems, you need to get yourself into the habit of trying to draw the picture. Okay? Look at what you're given. They all are going to start the same way. You're going to draw the bell-shaped curve. What goes in the middle of the bell-shaped curve? The mean does. What is the mean in this problem? My mean is $1.17. So this is 1.17. Okay. Now, what is the value that we're looking at? We're looking at $1. So $1.17 is more than $1, so somewhere on the left-hand side I'm going to draw $1. Okay. Now the question says, what is the probability that a randomly selected soda is less than $1? Well, less than $1 is the left-hand side. So we are looking for less than $1. Now, guys, these are not z-scores. This is actual data. How do we convert the actual data into a z-score? Well, how do we find a z-score again? Z equals observed minus expected over standard error. In this case, the observed, or what we found, what we're looking for, is $1 minus the expected of $1.17 divided by a standard error of 11 cents. If you do the math, you end up with a z-score of negative 1.55. Well, what's the probability of finding a z-score of negative 1.55? Use your blue chart. Look it up. If you look it up correctly, you should get 0.0606 or 6.06% probability that you're going to get a soda that costs less than $1. And that's all there is to it, guys. All we're doing is taking a set of data and we are standardizing that data and then using our blue sheets and finding our probabilities. Okay? Let's look at the next problem. Question number 2. On average, a fast food combo meal has 1,625 calories with a standard deviation of 243 calories. Assuming a normal distribution find the following 3 probabilities. Over 2,000 calories, between 1,500 and 1,700, and then C, between 1,000 and 1,500. Again, picture first. So for part A, let's draw our picture. Our mean is 1,625. And for part A, we want over 2,000 calories, so 2,000 is this side. And we want more than, so we want to the right. So since we want to the right, what are we going to have to do? Once we standardize this and find our z-score, the area that we find will be to the left, so we're going to have to subtract that from 1 to get the area that we really truly want to the right. All right, so let's standardize it. I keep saying normalize, I mean standardize. So the observed is 2,000 minus the expected of 1,625 divided by the standard deviation of 243. Gives us a z-score of 1.54. Well, a z-score of 1.54 gives us a probability of 0.9382. But again, remember, this probability is to the left of 2,000. We don't want to the left, we want to the right. So what do? We take our 1 and subtract 0.9382 and come up with our final answer of 0.0618. And that is our solution. For part B, we went between 1,500 and 1,700. So once again, draw yourself a picture. See where you are. 1,625 is here. Here's 1,500. Here's your 1,700. We want this area in between. So once we standardize this, the z-score for 1,700 will give us everything all the way over this far. The standard score for 1,500, the z-score for 1,500 will give us everything from here over. So if we take this score minus this score, that gives us our area in between. But again, we have to get the two probabilities first. And before we do that, we have to find our z-scores. So we're going to have to do two z-scores. So the z-score of the first one is 1700 minus 1625 divided by 243, which is negative, no, that's not negative. That is 0.31. And the z-score for the other one is going to be 1500 minus 1625 over the 243 calories, which gives us a negative 0.51. So when we look these up, the 0.31 gives us a probability of 0.6217. The negative 0.51 gives us a probability of 0.3050. And what did I say that we need to do? Subtract them. So we simply have 0.3167. So our probability of getting a meal that has between 1,500 and 1,700 calories is 0.3167%, or 31.67%. Okay. Now what about part C? Part C is said between 1,000 and 1,500. So again, draw your picture. Okay. We still have 1625 way up here. We still have 1,500 right here. And we have our 1,000 right here. So what do? We fill in between 1,000 and 1,500. Now the nice thing about this is we already found the z-score for 1,500. That's not going to change just because it's a different problem. The number is still the same. You still do it the same way, 1,500 minus 1,625. So the z-score for 1,500 is still going to be negative 0.51. We do need to find the z-score for 1,000. So we have z equals 1,000 minus 1625 over 243. Which gives us a z-score for this particular part of the problem of negative 2.57. Well, you've already found what the probability is of negative 0.51. You found out in the last problem. That was 0.3050. What you need to do is you need to look on your table and see what the probability of negative 2.57 is. And if you look very carefully, you find that that is 0.0051. So once again, I want everything in between these two. So if I subtract the larger one from the smaller one, that'll give me my answer. So that gives me 0.2999. Or the probability of getting between 1,000 and 1,500 calories in a combo meal is 29.99%. Okay. All right. So now let's take a look at our third of 4 problems. Okay. Number 3. The time a student spends doing stats homework has mu equal to 35 minutes and sigma equal to 7 minutes. If normally distributed, find the probability a random student will spend A less than 20 minutes, or B, over 1 hour. So, for part A, we are looking at our normal distribution. Hopefully you all remember that mu is of 35 means that the average is 35, so we have 35 here. And what do we have? We want less than 20 minutes, so here's 20, that's less than 35, and we want to the left. Well, this is the easy one, right guys? So let's go ahead and do this problem really quickly. Our z-score is going to be 20 minus 35. Please make sure you do that in the correct order. Observed minus expected. Expected is always the average, divided by 7. And that gives us a z-score of negative 2.14. Well, looking on your table, or in your blue chart, that gives us a probability of 0.0162%, or 1.62%. Not very probable that you'll find a random student doing 20 minutes or less than 20 minutes. What about B? Over 1 hour. Now guys, pay attention to your units. This was in minutes, correct? So this is 35. Please do not put a 1 down here for 1 hour. Please put a 60 up here for 60 minutes. And again, we want over 60 minutes, so we're going to the right. So what are we going to have to do? We're going to have to subtract whatever our probability is from 1 to get the right answer. So let's get our z-score. Again, our observed is 60 minus 35 over 7, and that happens to equal 3.57. Okay. Well, now, wait a minute. That's not on our table. The higher this number is, if it goes off the table, that's basically a 100% chance. Okay? So that means that what do we have? We have 1 minus 1, because we want everything to, remember, we have a 100% chance of getting everything to the left, which means we have what chance of getting stuff to the right? That's a 0% chance, guys. So based on this data, if it's normally distributed, you're not going to find a student that spends more than an hour doing homework based on this data. Okay. Number 4. Gamblers spend an average of 3.25 hours per day gambling. Okay. If the distribution is approximately normal, with a standard deviation of 1.42 hours, find the following probabilities. A, between 2 and 5 hours per day, and B, at least 4 hours per day. Okay. So for part A, again, draw your normal distribution. put your mean on there. The mean in this case is 3.25. We are looking for between 2 and 4 hours, so we're looking for this area. Hopefully by now you realize once we get our z-scores and we get our two probabilities for 4 and 2, all you have to do is subtract them. So the z-score for 4 hours is going to be 4 minus 3.25 divided by 1.42, observed minus expected divided by standard deviation, which in this case happens to be 1.23. And the z-score for our 2 hours is going to be 2 minus 3.25 divided by 1.42, which happens to be negative 0.88, I believe. So let's find our z-scores for that. The 1.23 is 0.8907, and the negative 0.88 is 0.1894. Once again, we subtract these two because we want the area between them, and we get 0.7013. So there's a 70% chance that you will find a random gambler that's spending between 2 and 5 hours per day. Sorry, that means I need to change this to 5 and this goes to 5. But that's right. Sorry about that. I had 4 on my brain. For part B, where the 4 actually comes into play, you have to be careful to understand what it means by at least 4 hours per day. What are we really asking you for? We know it's something with 4. Are we looking for less than 4 hours? No, we want 4 hours or more, right? So in this case, we're looking to fill in the right-hand side. Okay. So now let's find our z-score. Z equals 4 minus 3.25 over 1.42. And in that case, we get 0.53. The probability that goes with 0.53 is 0.7019. I'm hoping you are saying to yourself that's not the final answer because I'm looking at what's going on to the right. So that gives me, so I have to subtract from 1, so I get 1 minus 0.7019, which gives me a probability of 0.2981 or 29.81% of the chance that there was a gambler spending more than 4 hours, or at least 4 hours there. Okay. So there is an assignment that's online for you, just doing some more of these problems. I hope that you guys are doing well, and I'll talk a little bit in the next video about some of the things that I'm seeing that you're doing not quite right on these other homework problems. All right, guys, thanks, and have a great weekend, and I'll talk to you again on Monday.